What's up? What's up? What's up, guys? It's still the great teacher. Am I still the great teacher? I don't know. But here we are. We're going to try something new because this one is not a complicated concept. So what we're going to do is we're going to discuss this lesson the traditional way, using a blackboard. And we're going to talk about the parts of a circle. Let's just jump right into it. I know this is pretty much like something that you've known for like a long time since you were like a kid, maybe even before school. You're like, oh, sir, I know what a circle is already. But do you know what the geometric definition of a circle is? Some of you might be thinking now, a circle doesn't have any sides, a circle is a shape, it's a flat object, whatever that may be. Now, we will define circle using a activity, a short one. You may try this at home too. All you will need is, if you're using a bond paper, because I'm using a blackboard, so it's going to be a big circle. So just using a bond paper, I suggest you have a string or a rubber band. But the whole point of it is that I will use this ID lace in order to fully define what a circle is. The first thing that you need to do before you draw your circle is you identify a fixed point. So I'll put a point here, as you can see, and I'll name this as point T. So what I will do next is to simply use the ID lace to draw the rest of the circle. So I'll put this one right here and start drawing my circle. I hope I'm making a perfect circle. Well, let's see. Okay. It's not that perfect, but it works. Okay. So in the context of this circle that you're seeing right now, we can define what a circle is, which I will show in this part of the video, but I will mention. So the first thing that is very important about a circle is the first part that we started with, which is this point right here. So point T is an important part of a circle. Why? We identify this point by a dot and the name of the letter. Point T is what we call as the center. Basically, this point is the center of the circle. At the same time, the importance of the center is that we use it to name a circle. So if the center is point T, we can say that our circle is T. The name of this circle is T. And we name a circle using symbols with a circle and a dot in the middle, and then the center. So point T. So what is a circle in general? A circle, based on what we did earlier, we use this ID lace as a representation that the points that forms the actual circle are the set of all points. And it is equidistant to a fixed point that we call as the center. The meaning of the word equidistant is equal distance. So basically what we're trying to say here is that this center fixed point is equidistant to any of the points that we have here, which is actually true. So that's why the word is the set of all points. It's because it is impossible for us to count all of these points in general. It's an infinite amount of points, hence the word set of all points. So in that case, we have already, again, explained what a circle is. So what is the next part that we have to explain? Well, if you followed through with the way that this one is discussed, we use this ID lace for a certain reason. This ID lace that basically states the distance from the fixed point to any point on the circle is what we actually call as a radius. So using the ID lace, I will locate another point, let's say here. I'll name this as point T. And what I have to do is I have to connect them. So I'll connect point T to point A. So if you look at this one right here, you will notice that the center and a point on the circle are connected. Hence, what we call as the radius. Basically, the radius is a segment because there is an ending. It's a segment. And what are the endpoints of said segment? Basically, the endpoint should be the center and any point on the circle. So that's what a radius is. So we can take note here on the side of the board that we have in this given segment TA as our radius. This is our part of the circle. Next, now that we have the radius all dealt with, we have here TA. What do you think should be the next part of the circle that we will discuss? Some of you might probably think, sir, is the next one diameter? Well, actually, the answer is no. We need to remember one other part of the circle before we go with the diameter to fully explain what a diameter is. And basically, what I will do here is that I'll draw a line here connecting 2 points on the circle. Let's say I'll name this as E, and then I'll name this as P. So as you can notice, we have a segment that we can name as EP. Segment EP. And this segment is what we call as a chord. So if you're wondering what a chord is, basically, looking at the image itself, we have a segment because there's an ending, and the endpoints being a point on the circle. So basically, a chord is made of a segment whose endpoints are 2 points that can be found on the circle. Now, why is it important for us to discuss what a chord is before we go with the diameter? Because it follows the same concept. But there is an important detail that you have to remember when dealing with a diameter. So let's say I will still draw a segment that passes through the center whose endpoints are also on the circle. I'll name this as G, point G, and I'm name this as point O. So therefore, we can say that segment GO is a diameter. The important detail that you have to remember about a diameter are a couple of things. First, a diameter is also a chord. Why is it also a chord? Because its endpoints can be found on the circle. What makes diameter a special kind of chord? Well, it is a chord that passes through the center being T. Hence, it passes through the center, it makes it a diameter. Other than that, a diameter has another special feature, and that is the fact that a diameter is twice a radius. You might be thinking, how does that work? If you look at GT, it's a radius. Similar with TO, it's also a radius. If you combine the measurements of GT and TO, that makes up the entire diameter, GO. So, not only is a diameter a chord that passes through the center, but also the measurement of a diameter is twice the measurement of a radius. So these are our segments that can be found on the circle. What other parts can we have other than segments? We can have lines. Now, the important detail that we have to remember about lines on a circle, there are different kinds of them. One of them is technically not inside, but outside. Let's say that I'll draw a specific line here outside our given circle. This circle right here and this line that I drew has a special relationship. I'll put 2 letters here, 2 points to name this. Let's say that the name of this one is C, and then it intersects at point Z. So as you can notice here, what I drew now has arrowheads. I hope you guys remember what these arrowheads imply. When you have arrowheads instead of endpoints, this means that FC is a line and not a segment. So our example here, line FC, is another part of a circle that we call as a tangent line, or basically a tangent. This tangent right here, as you can notice, it passes through 1 point on the circle, exactly 1 point. So you can notice we have point Z in this context, again, in this context. So depending on the example, it has different names. So this point Z, based on our figure, is what we call as the point of tangency. So if you want to understand what a point of tangency is, you don't have to make it complicated. The point of tangency is simply the point where the tangent line and the circle intersects. It intersects at point Z, or Z, I don't know how you guys pronounce that. So that's what we call as the point of tangency. Now, I'm going to use a different color for the next example of a line that is related to a circle, a part of a circle. So what I would like you to observe in our given circle is our segment EP, which is a chord. So what I'm going to do now is I'm going to draw a line that passes through that chord. So let's say I have here. I drew this orange line on top of a chord for a certain reason. We call this specific line, of course, it's not a tangent because it passes through how many points? E and P, that makes 2. So we call this one as a secant. A secant, I don't know how you guys want to pronounce it. Is there still space here? So we have line EP. This one is what we call as a secant. So the secant is simply this. It's a line that passes through 2 points on the circle. Is it possible for a secant line to pass through 3 or more points on the circle? Of course not, just 2. So in this case, the difference between a tangent line and a secant line is quite evident. You may think of it like this. A secant line is something that you may see inside for a certain reason. Some students would like to define it that way. The very reason why some students think, oh, a secant line is inside the circle, because a part of a secant line is a part of a circle. What am I trying to say here? If you look at this one, our line EP contains a segment which is EP. Meaning to say, a secant line contains a chord. And if you want to understand this better, you may look at your guitar strings, right? And then the circle. If your guitars are acoustic, not you, the guitar. If your guitar is acoustic, you might see that circle, right? And imagine that those strings, the part of the strings that are within the circle is your chord, and the rest of the string is your secant. That's how we can better explain it. Once again, the special feature of a secant line is that it contains a chord. So can a secant line also contain a diameter? Of course, because diameter is a chord. Can a secant line contain a radius? Of course, because again, it passes through 2 points on the circle. It can pass through the center too, but again, the word is on. Guys, if the terminology is on the circle, we're talking about this entire thing. Kapag in, you have the center and the other points that you can form here. May intersection dito, therefore there is a point, and blah, blah, blah. Please pay attention with the way they are defined. We use the words in, on, and so forth. Now, in this case, so that we can save time, you will also maximize the use of one image for our other remaining parts. Other than the radius, the chord, diameter, secant, and tangent, we can also talk about those with measurements related to degrees. Because this one can be in centimeters, meters, but how about for degrees? So we can talk about the following. First, we can talk about arcs. Now, in arcs, there are 3 kinds of them. And to better explain it, it is important for us to go back to a certain part of a circle first. The first part that we would like to remember is the concept of a diameter. The diameter, for example, GO, here, if you observe properly, it helps us identify the first kind of an arc, and that one being a semicircle. If you don't understand what I'm trying to talk about here, try to imagine your protractor. Your protractor is a semicircle. It's half of a circle. In the context of an entire circle, the diameter divides the circle into 2 parts. To make this much more clear to everyone, what I will do is I will highlight our diameter so that you can notice what the semicircles look like. I will use the color green even though the board is green already. I think it's still noticeable anyway. Yeah, okay. So this one right here divides the circle into two parts. Now the dilemma that we're gonna have is, how do you know that we're talking about a specific part of a semicircle? So the first thing that you have to remember is, if you look at this image, if I say that we have an arc or a semicircle that is GO, from G to O, am I talking about the arc from G to O or from G to O this way? That's why there is something that you have to remember in naming them properly. Being, first, if it's a semicircle, the rule is that we name this using 3 letters. So if you're wondering, how do you name a semicircle using 3 letters? So for example, what I want to talk about is this semicircle right here. All I have to do is to identify the points that it will pass through. So from G, it passes through P to A to O. The rule in naming a semicircle is you're going to need 3 letters. 3 letters only. So we can name this semicircle as arc, draw an arc, and then the name being GPO. You can have GPO. But at the same time, GPO is the same as arc GAO. What I want you to remember here is that GPO is the same as GAO. Imagine it as if it's a part of your life wherein you want to just talk about the endpoints. But sometimes you want to clarify what particular parts of your life you have to pass through. And there are some points in our life that we want to forget, right? So we can forget about 1 letter sometimes because we only need 3. Why am I doing this? I don't know. All I want to do is explain to you guys that the purpose of using 3 letters is basically to emphasize direction. If you use GPO, we know that this is the semicircle we're talking about. So how about if you want to talk about the semicircle right here? You can name it as GEO or GZO. I hope you guys got that one. And a special thing about a semicircle is that it is half of a circle. Therefore, the measurement of a semicircle is 180 degrees. So that's what makes a semicircle. Now, we only have 2 parts remaining, and I know the board is getting full already. So why is it important that when we talk about arcs, we start with a semicircle? Because the other remaining arcs depend on the measurement of a semicircle. The first one being what we call as a minor arc. From the name itself, minor, the minor arc is basically an arc whose measurement is less than 180 degrees. Less than 180, and of course, greater than 0. Is it possible to have a 0-degree minor arc? No. We're not talking about an arc anymore. There's no arc if it's 0 degrees. So it's important to remember that. So in this case, how do we know if it's a minor arc? We base it now on your semicircle. So if you look at GPO, you can identify a lot of minor arcs here. I'll use a different color, probably pink. Now, I'm not going to write it anymore. Instead, I'm going to show it on the screen. So we can have minor arcs such as GP. GP is an arc. You can see it? G to P is an arc. That's true. Same with P and A. It's a minor arc. GA is a minor arc also. AO is also a minor arc. PO is also a minor arc. Now, if you have been observing the way that I'm saying these parts, you have noticed that I'm only using 2 letters. Basically, it is an acceptable, or basically a rule. Why am I saying the word basically all the time? If you use 2 letters in naming an arc, it's automatically accepted as a minor arc. So if you say GP, the GP that we're talking about is this, not GP. That's a different kind of arc. Again, if you use 2 letters, arc GP, it's this one. Arc GA, it's this one. Arc AO, it's this one. So how about if you want to talk about an arc that goes from G that still ends with P but goes the other way around. That's what we call as a major arc. So if a minor arc is less than 180, greater than 0 degrees, we can say that a major arc is greater than 180 but less than 360 degrees. Because of course, if it's 360 degrees, that's automatically the entire circle. It's no longer an arc. It's like in animes, right? The entire circle is the series. A major arc is basically a big storyline. A minor arc is a minor storyline. Okay, imagine it like that. We can also identify the, how do I explain this? Like, in some cases, kasi like some animes are like one season only, they have this cut in the middle, right? Like 26 episode animes have 13 by 13. Yun yung semicircle ng mga animes, if you get what I mean. That's how it works. So now, here, for a major arc, it's similar with the semicircle. We name it using 3 letters. Because again, we're trying to emphasize direction. So once again, if ang minor arc natin na GP is from G to P, what I want to make sure that the major arc I'm talking about is also ending with G and P, I have to mention any letter that it passes through. So you can say GEP, that's a first possible name. GZP, that's another possible name. GOP, GAP. All of those different names talk about the same major arc. Once again, we use 3 different letters. Again, for major arcs and semicircles. While for minor arcs, we only use 2 letters. So in this case, in this recalling of parts of a circle, I know that the space that we're using is a bit small, hence the yapping on the board is everywhere. Okay, there's no board management here. This is the first time that I did this. So of course, I'll show the definition of terms below, but I hope you guys understood what these parts of a circle are and what do they mean, and at the same time, how to name them properly, how to label them properly. The best thing that I can suggest to all of you is to simply, you know, be a kid here. Try to use your colored pencils maybe to highlight them better so that you will not be confused, okay? Before we go, once again, the parts that we have mentioned, the center of a circle is what we use to name a circle. So if the center of the circle is point T, we can name the circle as circle T. At the same time, our radius is a segment whose endpoints are the center and any point on the circle. A chord is basically a segment whose endpoints are on the circle. A diameter is a chord that passes through the center. At the same time, a diameter is twice the measurement of a radius. Next, we also have a tangent line. A tangent line is a line that intersects the circle at exactly 1 point, or it passes through the circle at exactly 1 point. That 1 point we call as the point of tangency. At the same time, we have what we call as a secant line, or a secant, or a secant, whatever you want to call it. It's a line that passes through 2 points on the circle. At the same time, not only does a secant line passes through 2 points on the circle, it contains a chord. And for the arcs, we have a semicircle. A semicircle, its measurement is 180 degrees because it is half a circle, which is 360 degrees. We can identify a semicircle based on a diameter. A diameter cuts a circle in half. Remember that. We have a minor arc, which we name using 2 letters, whose measurement is less than 180 but greater than 0 degrees. Degree. At the same time, our last example here, a major arc, it's greater than 180 degrees but less than 360 degrees. Similar with semicircle, we name it using 3 letters. Hence, these are the parts of a circle. I hope it all made sense. I repeated it like a lesson. I yapped for almost 30 minutes. Please forgive me. I'm bored. I tried this for the love of the game, I guess. So yeah, I hope you guys understood these parts of the circle. because we're going to use them and we're going to maximize them in order for us to learn theorems, corollaries, and other concepts related to circles in the future. You guys understand this one? Always remember, what's up? And in case you don't see me, good morning, good afternoon, good evening, and good night. Respect everyone. Peace out.